Welcome to our course on statistics for computer science. In this first video, we'll explore the fundamental concepts of statistics and see how they are applied in the field of computer science. Let's dive right in. Statistics is the science of collecting, analyzing, interpreting, presenting, and organizing data. It's about making sense of data and using it to inform decisions. Let's break down some of the basic concepts you'll encounter in statistics. First, let's define some key terms in statistics. For example, let's say you are considering some statistical analysis on social media users. Here you will consider all users of a social media platform. This will be your population. Then, for instance, you might select 1,000 randomly chosen users from that social media platform to study. This is going to be your sample, which is a subset of the population that is used to represent the entire group. You might consider the features for your study as any characteristic or attribute that can take on different values, such as age, gender, or the number of posts made by users. These will be the variables. Then from the sample, you might consider a single or a combination of variables of the users. This will be your data for the study. We will be using these concepts in our future videos, so keep them in mind. Now, let's explore how these concepts are used in computer science. Here are a few key applications. Algorithm analysis. Statistics helps in analyzing the performance of algorithms by evaluating metrics such as time complexity and space complexity. For example, we can compare the average runtimes of different sorting algorithms on various datasets. Machine learning. Statistical methods are foundational in machine learning. Techniques like regression, classification, and clustering are all based on statistical principles. For instance, using linear regression to predict house prices based on features like size, location, and number of bedrooms. Data mining. Statistics is used to discover patterns and relationships in large datasets, helping to turn raw data into useful information. An example would be identifying purchasing patterns from transaction data to recommend products to customers. Artificial intelligence. In AI, statistics helps in creating models that can make predictions and decisions based on data. For example, developing a recommendation system for movies based on users' viewing histories and ratings. Network security. Statistical techniques are used to detect anomalies and potential security threats by analyzing patterns in network traffic. For example, monitoring login attempts to detect unusual patterns that may indicate a cyber attack. Statistics helps us make sense of data through two main types of analysis: descriptive and inferential. Descriptive statistics summarize and describe the features of a dataset. Inferential statistics allow us to make predictions or inferences about a population based on a sample of data. To better understand descriptive and inferential statistics, let's consider a couple more examples. Descriptive statistics. One example is summarizing the test scores of a class of students by calculating the mean, median, and mode. Another example is creating a histogram to visualize the distribution of ages in a population sample. Inferential statistics. For inferential statistics, consider using a sample of voters to predict the outcome of an election. Another example is conducting a hypothesis test to determine if a new drug is more effective than an existing one based on trial data. Let's look at a practical example. Suppose you are developing a spam filter for emails. The process involves several steps. Data collection. Gather emails and their labels. For example, you might collect 10,000 emails, with 5,000 labeled as spam and 5,000 as not spam. Descriptive statistics summarizes the data to understand common features of spam emails. For instance, you could calculate the frequency of certain words or phrases in spam versus non-spam emails. Inferential statistics uses the sample data to train a model that predicts whether new emails are spam or not. An example is applying logistic regression to determine the probability of an email being spam based on word frequencies. That's a brief introduction to the basic concepts of statistics and their applications in computer science. In the upcoming videos, we'll delve deeper into these topics and provide you with the tools you need to analyze data effectively. Thanks for watching.